midpoint, partition of a line. So we're still using the idea of finding a portion of a line that's given from one point to another. Now we're actually finding a part of it, which is one of the parts of the word partition. So it seems like a very convoluted process, but I'm going to try and walk you through it so you can kind of understand what exactly is taking place. Let's go over some of the basics before we go over the examples. So one of the things to remember is that anytime you are given a ratio for this, it's talking about, well, we know that EG is going to be 2 parts out of the entire line, and we know that F to G is going to be 3 parts out of the entire line. That means we have a total of 5 parts. That also means that E to G is 2/5 of the entire line, and F to G would be 3/5 of the entire line. This takes an understanding of what that actually means to be able to interpret that's a part-to-part relationship, and we need to turn it into a part-to-whole. The x values distance, that can be done by simply calculating, and I'm going to show you that here in a moment. It can also be done by counting the rise and the run. So the run would be the difference in your x values. How far do I go left or right to get from one point to the other? And then the change in your y values would be how far up or down I have to go to get from one point to the other. All of that is going to then be multiplied by your ratio for the partition. And then you're going to need to add it on to your starting point, because that starting point is not necessarily going to be 0, 0. So those are not going to be the new coordinates. We have to add it on to our starting point to move those points down along the line. I'm also going to show you how that works in creating similar right triangles for slope. So let's take a look. I'm always going to start with actually writing down the coordinates. So F is 4, 8. And G is 12, 4. Okay. So what we've got going on here is just some real simple math. All right. So if we're going for change in X, we could say, how do you go from 4 to 12? Well, it'd be a positive 8. How do you go from 8 to 4? It'd be a negative 4, minus 4. All right. So that would be the change in X and your change in Y. How does that tie in to rise and run? Well, let's take a look. If I start at point F and I count over horizontally until I'm above point G, you're going to see it's been positive 8. 1, 2, 3, 4, 5, 6, 7, 8. There's the positive 8. If we go from where G was, or where F was, down to G, then we're going to see we're going to decrease by 4. 1, 2, 3, 4. There's the negative 4. We know this is also taking place, and it's going to be down 4 because this is a negative sloped line. So anytime you have negative slope, it's going to affect your rise and run appropriately, which in this case, it's going down by 4. Now that we have 8, negative 4, we have to remember we're finding a 3-to-1 ratio, and we're trying to find H. That means where the 3/4 of that line segment is going to end will be point H. So that means we have to take 3/4 of everything that is right there. So 3/4 of 8, well, 8 divided by 4 is 2. So we have 3 of those, 2, 4, 6. 3/4 of negative 4, 1/4 of negative 4 is negative 1, and we have 3 of those, so negative 3. This is going to be the distance and how much this changes. So we had the full rise and run, 100% of it, or 4/4 being positive 8, negative 4. We have 3/4 of that, which is going to be 6, negative 3. That does not mean that the coordinates are at 6, negative 3. What I'm going to do now is I'm going to show you a similar right triangle with rise and run that will ultimately get us to the point, but that is not the coordinates to where we're trying to get to. So let me just show you real quick. So 3/4 of 8. So we went over 8 initially. Now we had 3/4 of that. So I'm going to go over 6. 1, 2, 3, 4, 5, 6. This is going to create another similar right triangle with the same proportions. Then we're going to go down 3. 1, 2, 3. This is where our point is going to end. That's going to be point H. Now let's go the mathematical route without using the picture to see if we can get this done. So now that we know that we're going to have to adjust by going 3/4 of the distance, we're going to have to go right 6 and down 3 from where the starting point is. That starting point was at 4, 8. So what we need to do is we need to add 4, 8, and then that will get us right 6 and down 3 from the point 4, 8. So 6 plus 4 is 10. Negative 3 plus 8 is 5. And you can see that we are at 10, 5 for point H. Now let's go ahead and go through one where it's not using a picture, and we're just going to go through it mathematically. So we have S and T. I'm going to do my change in X and my change in Y right here. So that would be 2 to 16 would be plus 14. 17 to 10 would be dropping by 7, so minus 7. That gives us a ratio of, 2 to 1 basically. But what we need to do is we need to find a ratio of 2 to 5, but it's not 2 to 5. The thing we got to remember is that it's 2 parts over here and 5 parts over there, giving us a total of 7 parts for the entire line. So what we're looking for is 2/7. We're looking for 2/7 of that change. So 2/7. 2/7 of 14 is going to be, well, 1/7 of 14 is 2. So then 2 of those would be 4. 1/7 of -7 would be -1, so 2 of those would be -2. So now I know that I have a change in my X of 4, a change in my Y of -2. Now all we have to do is go to the starting point of the line, which was 217. Add it onto there, and it will make the appropriate adjustment by moving 4 to the right and 2 down from the point we started. So that will be 6 and 15. This is going to be point U. So the key thing to remember here is that your part-to-part ratio that it's asking you to do, like 2 to 5, is actually saying that's a part-to-part. We need a part-to-total, 2 to 7.